Okay, so here we are with the demonstration of how we can map the network, identify live machines, and then find and fingerprint working services. So I will announce that beforehand, just for everyone to be aware. Most of the tasks you are encountering in this phase of penetration test are possible to be accomplished by NMap, by using NMap only. Okay, so this Swiss Army knife of network engineering is not something figurative, right? It literally is a tool that can perform very different tasks at very high capacity. There are special cases, very narrow edge cases, I would say, when NMap, due to its universal approach to everything that it implements, right, they are just done better or faster or more accurately by some special tools that are way less maintained, yeah, and well less dynamically developed as NMap. So still, if you know syntax of NMap and you have this experience of using it in different environments, you will know networks better, you will know the specific penetration testing related activities better. So you have to know it, you have to go through the syntax and use most of the options. You will never use all of them for a good reason, I'm almost sure, but still you have to know that there are things that even professional penetration testers who are out in the field for more than 10 years, I show them some tips, some tricks, yeah, and they are really impressed and surprised. So let me walk you through the syntax, and then we will use NMap for some Yahoo scanning, of course. So NMap help page looks like this. Let's start one by one. First of all, we'll have to do some target specification. As I said, there are different notions of targets here. Yeah, so there are different examples. You can take it as that you can give a host in any possible way, right? You can do DNS name, you can do IP address, you can do DNS name and then separate netmask by slash, right? So this CIDR format of identifying networks in the internet. This will be a class C network that the host that Microsoft.com will resolve to is located in. Yeah, so this is kind of tricky. This is not a formal and accurate definition of targets, but NMap can do that, and you have to know that. You can just give an IP address. Okay, so this will be limited to one host on the network only, most probably your default gateway, yeah. And this is how ranges can be configured, yeah. So take a note here and remember that doing ranges between network numbers or host numbers is not what NMap is able to, yeah. So you can give ranges in different portions of IP address, right? So this will be like 256 C-class networks, yeah, each containing a bunch of addresses, yeah. So this will be like /16 in fact, yeah. But you can do that here, yeah. So that's how NMap is different from all other things, I guess. many tools that are claiming that they follow NMap command line syntax, in fact, don't implement this functionality. You will see it later. Okay, so this is the most important. This is what you give to the command line. you can save your input ranges to files. So everything that you can put into the command line, you can put also into different files, and then feed it to NMap by -I capital L. So everything that will be written in these files will be treated line by line as possible targets for scanning. Okay, you can, as far as I know, you can do that multiple times within one command, but yeah, I cannot find a good reason for that from the top of my head. So yeah, it's better to keep everything in files to keep it organized, and as you evolve through network enumeration, just update the files you already have or create new ones. And remember, the names of these files should be descriptive, right? So in the history of your command execution in bash, for example, or in the directory that is dedicated to the results of your scanning, you have to be able to figure out what contains what without looking at it, because when you use NMap, when you scan really large networks, the number of files you generate grows really fast. Okay, and this is -I capital R. This is just the randomization from the host that you have fed to NMap. It will put it into some pseudo-random generator, right? And it will give them numbers and then pick them at random and scan, yeah, in that order. Why is that so? Sometimes, and some tools, due to their functionality specifics, yeah, they do that by default. But sometimes you have to pretend that your traffic is not structured. Yeah, so that, yeah, you are running NMap, but you have to make it look like it's not NMap. It's just a random bunch of connections going into client's infrastructure. Sometimes to avoid attention, sometimes to avoid automated detection, sometimes just to not melt down the connection client has. Yeah, so the client, for example, has multiple networks connected via multiple different types of equipment, and you want to spread your influence equally through all the infrastructure. This is a good idea, actually. You will still melt down your uplink, yeah, if you do it at large rates, at high rates, but you can let your client's uplinks survive, yeah. Okay, so this is how you exclude something that you put into command line, and this is how you exclude something that is in your files. For example, you have really firm exemptions from your penetration testing scope. You want it to be written down somewhere and used like that. So now, what can we do for the first part of our demos, right? How to discover hosts. The most important thing you can use here is this -sn. Yeah, so remember to do that with -n, yeah, not to resolve everything, because again, DNS is really slow. It will slow you down, especially on large network sizes. This will basically not do any host discovery. So if you want to do TCP or UDP scan and assume that all hosts in the list that you fit to NMap are up, you use this -Pn or -P0, which is basically an equivalent of that. Also, when you are using different discovery techniques, you can ping by not only SCMP, but different other protocols, yeah, like TCP, UDP, SCTP, and yeah, and something else. Yeah, so you can get a port list of the most used services, yeah, in the network, and then use them just to identify hosts. Why not? This will be not that accurate as if everything is up and responding to SCMP requests, but still, you can do that in different situations. Okay, so This is using echo timestamp or net request in ICMP. So by default, it's of course echoing the hosts, but you can change that manually. And this is just using IP protocol. Different IP protocols to do that. This is a really rare case. We will not stop there for long. Okay. You can use different DNS servers, not those that your OS session is configured with, but something else, for example, Google's or OpenDNS or something. And yeah, you can do traceroute every time you scan, just to show that trace in the end of scanning every network or every host. That can be useful just to figure out where everything is located. Now, what about scanning services? For scanning services, as I told you, there is a number of different things how to establish connection or establish it at all. Yeah, so you have to decide that. SYNSCAN is slightly faster. Full connect scan is logically slightly slower, but these are two you will use the most. Yeah, so if you have some firewall interference, you most probably will want to connect fully. If not, you most probably will use NMap as root, and by default it will SYNSCAN. Okay. There are other ways to do that. You, for example, can just send X. Yeah, so not sending SYNS, but starting from sending X right away. That's unusual, and you will receive an error. But based on that error, you can assume whether service is up or not, whether it's there. Okay. This is how you make NMap understand that you want UDP scanning at all. -S_U. These are different combinations of flags and different approaches to scanning that are not appropriate from the TCP protocol standpoint. Okay, so from TCP protocol point of view, this is like abusing the protocol, but there is nothing illegitimate in there. You can generate any packet and see what happens, but yeah, that can lead to some kind of implications. So every time you use this, or you use very intensive scanning techniques, yeah, you have to remember that there are still some legacy boxes out there, and there is software that literally, if accessed in a way that it does not expect you to, can just reboot itself. I were in the situations like that, you know. So there were just this box that counted money, yeah, for a large company, and it was basically a component of billing system. I will tell you more. So sending 3 specific packets by NMap to that box caused a service in it to reboot. So just restart it, and for some time it was irresponsive, yeah, and everything that was going on during that period of time, those couple of minutes, yeah, was unaccounted, right? So this is not the end of the world, but still, this is something not really pleasant when you are talking to network and system administration guys afterwards. So yeah, be prepared that there is a lot of crappy code out there, and even these things, when run for the first time, for the first couple of times, even if this is like some recurring process, you want to monitor your network periodically, for the first couple of times, just be very careful and be there and observe what happens, because if a host stops to respond, yeah, for example, you want to be there, see that, and contact whoever is required in order to figure out what happened, and then start it up again. Okay.